So they've given us a graph of the inverse of f, not f, but the inverse of f. And look, it's cubic with a term that's to the first power, so can't really get the inverse of f of x directly. So they gave us a graph of the inverse. We're supposed to graph the tangent line to the inverse at the point -2, 1. So the tangent looks like it might be something like this. But to figure out exactly what it is, somehow we got to use f of x to find the inverse. So let's go over to a whiteboard so we can see what's going on. One thing we recently learned in the course was the chain rule of derivatives. So if we take that and the fact that, take that in the definition of an inverse, where if you put an inverse function into an original function, it gives you the identity. This is something that we can differentiate with respect to x, and maybe we can come up with a formula. We want to know what the derivative of the inverse is. This is what we're looking for, the derivative of the inverse function. So if we can solve for that, then maybe that can help us with our problem. So if we want to differentiate both sides using our new calculus tool, the chain rule, it's the derivative of the outermost function with the innermost function kept the same times the derivative of the innermost function. And there is the thing that we're trying to isolate by itself. Here is the derivative of the inverse function. And then a derivative of x is just 1, right? So this is what we want to get by itself. So let's divide this from both sides. And so this is the formula you're going to need to use for these types of problems. And it looks yucky, but what this formula says to do, it says take the derivative of f, which we can find real quick. Using the power rule, that's -3x squared plus 4. So we got the derivative of f, and I'm actually going to screenshot this just so I don't have to write it again later on. So we got the derivative of f. This says we're supposed to plug in the inverse everywhere in x in the derivative. So for our particular problem, and remember this always depends on f, so you're going to have to redo this every time. This is the starting spot for these types of problems. You're going to have to redo this step every time, which means the next step that I'm about to do is going to be different every time. So the derivative of f is -3x squared plus 4. But instead of x, I'm putting in the inverse let's see. And then so I think we're where we need to be. So if we're trying to find out what the derivative is, because we're looking for a tangent line, so we want the derivative when x equals -2. So that means we're plugging in -2 in for x. Let's see. There's some algebra we could do. No, okay, that's the derivative. Okay, so I think the only thing we can do to evaluate this, the inverse at -2, is to go to the graph. Okay, because look, right now, actually we have this. This is something we have. I'm sorry. Right now we don't have the inverse of f. Can't find it, but we have a value when x equals -2. We know the y coordinate is 1 because they're telling us that this is a point that's on the inverse. So instead of writing the inverse of f at -2, we know what that corresponding y value is. It's 1. So we square 1. We got -3 times 1 makes -3. -3 plus 4 makes 1. So it's 1 divided by 1 makes 1. So on our graph, here's our point, -2, 1. We should go up 1 and to the right 1 for our next point. So we're asked for a graph of, we're given a graph of, yeah, it's the same deal as the other problem, right? All right, so let's go back to that notation that we derived, that the derivative of the inverse is 1 over the derivative of the original function with the inverse plugged in. I guess to make our lives easier in this one, let's just jump right to the notation where we're plugging in 3 into the inverse function. And then here, while we're at it, let's find the derivative of f. That's just going to be -3x squared. So it's -3, and then this is the inverse with 3 plugged into it. And we have the corresponding y value. That's -1 for a y value. Don't know what happened with my mouse there. There we go. I think that's it. I think it's just 1/3 for the slope. And then we already have a point. It's y equals 1/3 x plus b. Plug in -1 for y, because that's a y coordinate on the inverse. We're going to get -2 for b. So y equals 1/3 x minus 2, or maybe we could just count out the slope on the graph, right? It's at the point 3, -1. Here's 3, -1. And then we got a slope of 1/3, which means we go up 1 to the right 3. Oh, I did something wrong, because this doesn't make any sense. That's not the tangent line, right? Go up 1 to the right 3. That's not tangent. It's almost the opposite. So maybe I dropped a negative sign. Let's see. The derivative of f of x is -3x squared. That's right. Oh, I dropped a squared. Right? -3x squared, -3. This is where x goes. I dropped the squared here. And I don't think that's the first time I've done that. So that makes a -1/3. So starting from this point, we need to count down 1 to the right 3. There we go.